Okay, so here are some examples for roots. Given roots, determine other roots. So given the following roots, list the missing root or roots. We have a root of 3. We have 2 plus 7i, that is all one root. And because we have a 2 plus 7i, we have to have a 2 minus 7i. So this is the missing root out of that set. Remember, our i's always come in pairs. So it means we have to have a plus and a minus. If this had been just 3 and 2 and 7i, then we would be missing, let's change colors here, we would be missing a negative 7i. If we look at B, we have 3 minus the square root of 2. That means we have to also have 3 plus the square root of 2 as our other root. One more time as a different example, if we'd have 5 and root 2, then our other, let's change colors again, our other missing root would be negative root 2. We will always have a positive and a negative radical. Look at the next section. We have given the following roots. Determine the polynomial based upon the roots. So this is where we're going to write out the polynomial given the roots. And here we're going to have x equals 2, x equals 5, x equals 3i, and that's a positive 3i, and that means we also have x equals negative 3i. When we write these out as factors, we're going to subtract 2. So that gives us x minus 2. We're going to subtract 5. That gives us x minus 5. We'll subtract 3i. That gives us x minus 3i. And then we're going to add 3i for this one. That will give us x plus 3i. And here is what I will do when I'm working these kind of problems. I will go ahead and do these together, because what's going to happen is I'll have my x, and my x is x squared. I have x times a positive 3i, and I have an x times a negative 3i. Those two are going to cancel out. They are complex conjugates, and the middle terms are going to cancel out. So what we wind up with is negative 3i times positive 3i, which is negative 9i squared. We learned before that I squared is negative 1. So this is x squared plus 9 coming from a negative times a negative. Now I can take this and multiply by either of the other two binomials. I would just go and do x minus 5, multiply through that one, and then go back and pick up the x minus 2. So that's kind of how to do those. And just to lay out the factors for B, I have 4, or rather x equals 4, x equals 2 plus root 5, and x equals 2 minus root 5. Remember, radicals come in pairs. So when I subtract 4, I get x minus 4. For this one, I need to subtract 2 first. So I get x, well, that's not the best way to do it. Let's go back. Where's my eraser? There it is. There we can I get the eraser? There we go. Let's go back to drawing. Change colors. I am going to go ahead and subtract the whole thing together. Equals 0. So now I have x minus 2 plus root 5 equals 0. And if I do the same thing with the other one, I'm going to subtract to get x minus 2 minus root 5 equals 0. So my factors are x minus 4, x minus 2 plus root 5, and x minus 2 minus root 5. And that's a lot. It's crazy. Here's the good news. Oops, I left off a parenthesis and I left off a parenthesis. Here's the good news. I'm not going to do one of these to you on a test or a quiz. What you would expect is something with just a root 5 and a minus root 5. Not anything with a complex radical there. So that's kind of an overview of what's going on. And if you have any more questions, please let me know. Thanks and good luck.